Hello, I am Dr. Chandel Murugan, Mechatronics Engineering Department, K.S.Rangasamy College of Technology. I will discuss about Pascal law and its applications. In general, Pascal law is defined as in a static liquid, pressure is equally transmitted. In elaborate, in a fluid at rest within a closed container, any change in pressure applied at one point is transmitted undiminished throughout the entire fluid and to the wall of the container. This is often referred to as the Pascal law pressure. Simply, you will apply a small force at one end. This confined liquid transmit the pressure equally to the another end. Due to this, we will get a larger output. This is the Pascal law formula. Exactly how pressure is transmitted through a fluid. If a pressure P is applied at any point in a confined fluid, the same increase in pressure occurs everywhere within the fluid. We know pressure is equal to force per area, where P is equal to pressure applied in Pascal, F is equal to force applied in Newton, A is equal to area over which force is applied, that is in meter square. So, in this hydraulic system, we will see how the Pascal law is used. Pascal law only applicable for hydraulic system because hydraulic is incompressible. See, the piston end and the plunger end, generally it is called as a plunger end and this is the piston end. Both are having a equal area. So there is no multiplication of force. If there is a different area, this one is the small area and this one is the larger area. So we will get a larger output here. Now we will see this explanation. See, we know Pascal law is always pressure is equally transmitted. So P1 is equal to P2. What is P1? P1 is equal to force per area. So F1 by A1 and P2 is equal to F2 by A2. Here the area, assume it is A1. Here the area is the larger area. You can assume it is the 10th time larger than this A1. So this is 10 into A1. So pressure is equal to force per area, then force is equal to pressure into area. Yes, small force applied here. Then as per Pascal law, pressure is equally transmitted. We can able to multiply the force and lift the heavy load. This is the concept of Pascal law. This one is hand operated hydraulic jack. This consists of oil tank, two check valve and pump piston, lever and load cylinder. See, whenever the pump pistons moves upward, the hydraulic fluid from the reservoir through this check valve, because this check valve allow this hydraulic fluid, then it will go and fill this pump piston. Whenever the pump piston gets downward, then the pressurized hydraulic fluid goes through this check valve too, then go to the load cylinder, it will have the load. This process is repeated continuously until our load reached specified distance. After this, we can open this bleed valve. All the liquids in the load cylinder will comes to the oil tank. This is the hand operated hydraulic jack. This one is the air to hydraulic pressure booster. Using only the small amount of pressure from compressed air, we can clamp the workpiece very effectively. How? Because the compressed air will come, then the air piston is downward pressurized, and that pressure transferred to the oil contained here. Then this oil is going to here, that is, it is a static fluid already. So the pressure is transmitted to here. This is the larger piston. So due to the area difference, we will get the larger force here. So it will clamp the workpiece effectively. These are the applications of Pascal law used in hydraulic lift, used to lift heavy vehicles. A small input force on a narrow piston generates massive output force on a wide piston. Hydraulic brakes, the standard braking system in cars and trucks, ensure that pressure from the brake pedal is distributed evenly to all four wheels simultaneously. And also, these Pascal applications include hydraulic press, industrial press, and use this law to press scrap metals, mold plastic, or extract vegetable oil from seeds. Similar to lift, it uses a larger area ratio to generate hundred of tons of force from relatively small mechanical input. In aircraft, extending and retracting landing gear, adjusting wing flaps, and operating the radar. These are the reference. Thank you.